All right, so this is class number 3 for correlation and regression. So what we've done so far is I've just kind of introduced the ideas of regression and correlation. Last time we did this, we talked about how to calculate correlation and do a hypothesis test to see if there is a significant correlation, see if the correlation is something other than zero, basically. So today what we're going to do is move from correlation to regression. These two things go together, just like the mean and standard deviation go together. Regression is a measure of central tendency, and correlation measures how much things vary around that. So they are actually two parts of the same thing. The textbook, if you read through the regression part, it has a section on doing a hypothesis test for regression. I've decided to skip that since we've done a hypothesis test for correlation that also tests regression, so we don't need to do a separate one for regression. So if you're reading along the book, you can skip that. Instead, we're just going to focus on the use of regression line. And those three things involved in using regression is called fitting. That's actually just calculating what the formula is. And then using the fitted line to make predictions or to plot. So to get ready for today, make sure you have your calculator. Make sure you remember what we did from class 2. We need those calculations. And also I realized that I did not calculate the means last time, so we'll need the mean of x and y from our study in class 2 before we get started here. All right, so as a reminder, the study I came up with last time was based on the ratemyprofessors.com website. What I did was I found 5 different faculty members at random from Augustana, and I looked at this number, which is overall quality, and this one, which is level of difficulty. They're both on 5-point scales. And what I'm doing is I found a correlation between the two, meaning that if one of those numbers changes, I can make a pretty good guess about what the other one is. So that's what the correlation tells us. It's a significant correlation, so today what I'm going to do is use regression to see what that connection is like. This is the data I showed you from last time. I kind of dimmed the numbers here that you don't need to look at. If you need to review those, you can take a look at the second video in this series. But the important thing today would be the sums of squares, sums of products, and we need the averages, which I forgot to do last time. So I'm taking the average value of x is 14.1 divided by 5, 2.82. The average value of y is the sum of y divided by 5, and that's 3.88. So just needed to add that to the calculations we did last time. All right, so that's what the study is, and these are the data that we have. I'm ready to move on and do some regression. All right, so the first thing is fitting the line. In regression, there are several different approaches to it. We're doing what's called least squares or ordinary least squares, and we call it fitting the line, or the line of best fit. So basically what that is saying is that when we calculate this line, it's going to minimize the distance between the straight line and all of the dots in a scatter plot. And I'll talk more about that in the next video. But that's what these formulas that we're working with today will do. They will create a straight line that is the best fit line. It fits the dots, getting closest possible to all of them. All right, so the three things that are new here, that begins with y hat. I always call that y hat. It's just a symbol that represents the line. In the textbook, we have like x bar or y bar. I use the capital M with y to mean to indicate the mean or average y. y hat is actually kind of like, it's a measure of central tendency. It's kind of like saying the mean of y at a certain value of x. So y hat is the line itself. The way we find the value of y hat is with two coefficients. One of them is just the letter b. And you probably remember from algebra or even pre-algebra back in 8th grade or so that a straight line has the slope. And the way I remember it from back in the 80s is they called it rise over run. So that's the slope of the line. And the y-intercept, which I'm sure you also remember from pre-algebra, here is the letter A. And so that tells us where the line starts if x is equal to 0. All right, so put that all together. We have y hat is equal to A plus B times x. And once we find what A and B are, what we do is we come up with a value of x that we're interested in, and we'll solve for y hat. And I'll show you that in a couple slides. Okay, so first thing we do then is we fit the regression line. I've got the two formulas that we need here, and in the blue box up here I've got the values that we calculated for sums of squares and the means. So I just brought those up from some previous slides. Okay, so the first thing we do is we calculate our b value. That's the slope. And going back to our data, I found that SP is negative 3.01. Sums of squares x is 3.19. When I solve for that, I get a negative 0.94. The negative here is pretty important. That's what's going to indicate to us that we have a negative slope. That means as one variable increases, the other decreases. Okay, now that we have b, we can come down here and solve for a, the y-intercept. That's the mean of y minus b times the mean of x. So we have to bring b down. Let's start with this. The mean of y is 3.88. And the formula says minus. Now, b is also negative, so that's minus a minus. And hopefully that's not too frightening to you. If it's been a while since you've done some math, and that might throw you off, so I'll go slowly through this. And then the mean of x is over here. 2.82 is the mean of x. All right, so what we do is we have negative 0.94 times 2.82, and then once we solve for that, we actually add that. It's a negative, so we add that to 3.88 to get 6.54. So anytime you have a negative correlation, your slope will be negative, and you'll wind up subtracting a negative or adding that to the mean of y. Okay, down here we have the actual formula now. Y hat, the expected value of y, is 6.54 minus 0.94x. Since b is negative, that's plus a negative. That's just a regular negative. All right, so that is our line. We have now fit the regression line. We have a best fit line to work with. So the next thing I want to show you is how to make predictions. I just created a little table here with x and y hat. And the way that works is we'll use this table to say that if x is this, we'd expect y to be this. So I'm going to start with 1.5. Now I'm going to plug that into the formula here. If x is 1.5, I can now plug that into my formula where x goes and solve, and I'll get 5.13. Why 1.5? Well, I just kind of made that number up. What I wanted to do, I'm thinking ahead to the next section, which is I'm going to plot a line. So I just was curious about a number that's kind of low in the scale. The scale goes from 1 to 5. The lowest value of x is a 1. That means someone's incredibly easy as a teacher. So I just went somewhere on the low end of the scale and got a 1.5. You can literally use any number on the scale, or if you're crazy, you can even do something off the scale. I mean, I could put in 0 there if I wanted, even though that's not a possible value of x on the website. All right, so I'm going to do the same thing at the opposite end of the scale. The scale goes up to 5, so I'm going to get a high score like 4.5. Just out of curiosity, I put that in here in the formula for x. That gives me 2.31. So if x is 4.5, I'd expect y to be 2.31. Here's something cool. This is the mean of x. If I put the mean of x in here, solve for that, I actually get 3.88. And I don't know if you've seen this already, but the mean of x is 2.82. When I solve for that, the expected value of y is the mean of y. In any least squares line, the point, which is the mean of x and the mean of y, is always in the line. Okay, so I picked a couple like that. Now, if you happen to know an individual's x score, you can plug that in and make a guess about what their y value is. If you know what their y value is, you could actually, with just a little bit of algebra, solve for x and try to make a guess for how difficult they are. So that's how predictions work. All right, the last thing we're going to do is plot a regression line. So this is what you did in 8th grade when you got out the graph paper and started plotting things. What I did is I've got the x-axis here going from 0 to 5. The actual scale on the website goes from 1 to 5. Same for the y-axis. I just added the 0 because we were that close to 0, and it's kind of nice to be include 0 if you're that close to it. Okay, so on the left here I've got the observed values in blue. The observed values are the actual professors that I found. So let's take a look at those. I'm going to plot the actual observed values. The first person had a 3.5. So what I'm going to do is down here I'm going to draw a line at x is equal to 0. This person's x is 3.5, so I'm just going to move over to 3.5. For their y value, I'm going to start with y is equal to 0, and I'm going to move up to 3. So you can see I'm at x 3.5, y is 3. So I'm going to put a little blue marker right there. That is my first professor. Imagine that you remember doing this, but I'm going to do another one kind of slowly here. Second professor has, I'm going to do this in reverse. I'm going to start with their y value just for fun. So I'm starting at y is 0, and I'm going to move up to 4.7. So that's a 4.7 on the y-axis. And then I'm going to move over to 2.3 on the x-axis. There we go. And put another blue marker right there. All right, so there are the first two. Do this a little quicker here. Third one's there. Fourth one goes there. And the fifth one goes there. So those are my 5 professors right there. And you can see they actually look like they fit a really straight line. That's evident in the fact that we have a super high correlation for it. All right, now that's the actual data. If I want to do the regression line, I'd come down to here, and I show that these are values that represent y hat. Okay, I'm going to put the value that I predicted on the last page. I said if x is 1.5, y hat is up here. And then I'm going to do this value. If x is 4.5, the line gives me 2.31. And that goes there. And now I'm just going to connect those with a straight line. And you can see this is our regression line. This shows the trend in a best fit line. So that shows us that on average, a y value goes down very predictably as x goes up. All right, so that's how you plot the line. I showed you the scatter plot has the actual values of my data. The green line here and those two dots are actually y hat values that come from a formula. Okay, so that's pretty much what we do with regression. As I said, we're not going to worry about doing a hypothesis test just for that, but that shows you how to fit or calculate the line to make predictions with it and how to plot with it. Probably do one more video on correlation regression where we just talk about understanding the concepts and a few variations on what we've done so far. But that's it. I hope you found that a little less complicated than the last thing we did, which was factorial ANOVA.